Hello students, welcome to the class. So today we will see the theory part 8 of the chapter 9 hydrocarbon, in which we will cover the NCERT section 9.3.2. So let us start our class. This is our disclaimer. Now in this class our objective would be to look upon the nomenclature of alkenes. So we have already dealt with the nomenclature of alkanes, and we also have grasped the idea of doing the nomenclature in general in the chapter GOC. So we'll use that concept also here to do the naming of the alkanes. Now if I talk about the specific names of the sections that we are going to cover, obviously it is 9.3.2, whose name is nomenclature. Then after we will do some questions. So we are going to do the NCERT question 9.7 and 9.28, right? So let's start our class. First of all, I will give you a quick recap of the idea for doing the nomenclature, and that same thing will be overall applied to the nomenclature of alkenes. Apart from that, the extra thing that we are going to do is the question part, right? So we have set up some question for you, so especially which are related to the nomenclature of alkenes. Now we have seen this image, so this is a visual representation which will be used to name the parts of the nomenclature that we are going to see. Let us break down each part. So first of all, the structure for naming the hydrocarbon is in this way. So first we have secondary prefix, then we have primary prefix, word root, primary suffix, and then secondary suffix. Now what are these used for? First of all, the secondary prefix is used for any substituent group which is present in a hydrocarbon. So that substituent in the case of hydrocarbon is mostly alkyl, but if you have functional group also, then they can also be placed in the secondary prefix section. Now next we have primary prefix. This indicates that if your compound is cyclic or not. Okay. After that, we have to select the longest chain. So that is the foremost thing we do in naming. Now after selecting the longest chain, we use a root. So for 1 carbon we have meth, for 2 carbon we have eth, similarly for 3 carbon we have prop. So those are the word roots, and they depend upon the length of the main carbon chain. Now moving on further, what are these parts? Let us just discuss the remaining part. So 3 are being considered. So we are left with the primary suffix, secondary suffix. So what is primary suffix? So basically, this primary suffix is used for indicating the type of carbon-carbon bond which is present in your given hydrocarbon. Now, if it is a single bond, if all the bonds are single, then the primary suffix is ane, A-N-E, and it is used for a saturated hydrocarbon mostly. Then, if it is containing one double bond between 2 carbon, at least one double bond, then it will be having a primary suffix as ene, E-N-E. Then after, we have this Y-N-E, ine, and it is for at least one triple bond. If there is a triple bond present in the given hydrocarbon, then we will use the primary suffix as ine. Now, moving on to the secondary suffix. So this is basically used for functional groups. So two things are there which are used for functional group. So first one is the secondary prefix, and second one is the secondary suffix. Now, if there is only one functional group, in most of the cases, we indicate that functional group with the help of secondary suffix. And if there are two functional groups, then the one is considered as the main functional group or the primary one. So that is denoted by the secondary suffix, whereas the subsidiary one is denoted by the secondary prefix in most of the cases. Now this is possible that your given single functional group has no suffix for it. Yes, there are groups which have no suffix for it. In that case, we have to use their prefix only. Now let us talk about this rules for nomenclature of alkenes one by one. So first of all, we will list the suffixes and prefixes which are present in the compound. Then we will decide the word root. So how is the word root derived? Word root is derived from the longest chain that is possible in your given hydrocarbon. and that should include the double bond or the triple bond if it is present. Okay, so your longest chain, if it is there, then you should be keen that your longest chain must contain the double bond or the triple bond, means the unsaturation should be within that longest chain. Got it? Next part, we have the numbering part. So numbering is given to the chain in such a way so that the double bond gets the lowest possible numbering. Since we are dealing with this alkenes, so we are dealing with this double bond only. Okay, now we have primary suffix. So in case of alkene, the ane is replaced by ene. Got it? For alkenes. And if multiple double bonds are present, then you have to use a prefix along with this primary suffix, like di, tri, or tetra. So if it is 2 double bond, then it is diene. If there are 3 double bond, it is triene. If there are 4 double bond, it is tetraene, and so on. Next, we have to indicate the position of the double bond in this primary suffix also. Okay, so 2 things are there, I would say. First of all, you have to see that whether a double bond is present or not. If it is present, use the suffix ene. Okay, and that suffix will also contain the position of the double bond. How it is written, we will see it with the help of a proper example. Now moving on further, if you have assigned this secondary prefix, primary prefix, and secondary suffix, if it is present, then you will just do the complete nomenclature. So basically it is like putting the parts of a puzzle. So you are solving a puzzle and you are putting the puzzle parts in their proper position so that you can get the complete nomenclature, which is secondary prefix plus primary prefix plus word root plus primary suffix plus secondary suffix. Now we will do questions on it. Okay, so the question is the main part, I would say. So the first question is saying that, which is 9.7, it is telling us to give the IUPAC name of the following compounds. So we have a total of 4 compounds given here. We will deal with each of them one by one. Starting with the structure number 1. So this is your structure number 1. Now what is the first step towards its nomenclature? Is listing the prefixes and suffixes present in your given compound. So it will not have any primary prefix. Okay, primary prefix will be absent here. Then what about the secondary suffix? Is there any secondary suffix present here? No. So these two, primary prefix, which is used for cyclic compound, and secondary suffix, which is used for functional group, are not present here. But we have the secondary prefix, which is our substituent. So if you will select the longest chain, you will see that they have substituent for which we have to assign the secondary prefix. Word root is the mandatory one, and of course primary suffix is also the mandatory one. Okay, so the extra thing that we have here, apart from the mandatory ones, we have this secondary prefix, which is denoting our branching. Now moving on with the second part of this naming thing. So far we have listed the names of all the prefixes and suffixes which are present and which are not present. What is the next thing? It is deciding the word root. Okay, so how do we decide the word root? By identifying the longest chain, and that longest chain must include the double bond. So if that is the case, then looking at the compound clearly says that this is the longest chain which is possible. It includes 2 double bond, right? And apart from this longest chain, we have 2 substituents also. Now if you count the number of carbon in this longest chain, it is 10. Okay, so therefore the word root is dec. So this is the second part of our nomenclature. So we have listed the suffixes and prefixes. Then we have also seen through this longest chain. Now we'll continue our solution. Our next part is numbering the hydrocarbon. How you will do it? So numbering is possible in 2 ways. So either it can be done from the right or from the left. The option A is saying that you can start it from the left. Option B is saying that you can start it from the right. Option A gives us 3, 6 as the position of your substituents, whereas option number B gives us 4, 7 as the position of the substituents. Now which one is the good one or the appropriate one? For that, you have to use the lowest sum rule. So according to this rule, we can say clearly that the lowest sum is coming from option number A, which is 6 plus 3, 9, and it is smaller in comparison to 4 plus 1, which is 11. Therefore, according to this lowest sum rule, the correct numbering option is A. So we are done with this third step, which is numbering. Now let us move on to the fourth step. So the fourth step is primary suffix. Now we are already done with this numbering part, so we can do the work of assigning the primary suffix. How we will do it? We know that double bond is present here, and this double bond is -ene. So the primary suffix for this double bond is -ene, E-N-E, right? So you will not use -ane. In alkanes, -ane was there, but in alkene, -ene will be there because of the double bond present at third and sixth position. Now, two double bonds are present here, so you will use the prefix, especially for this primary suffix, as di. So it is a kind of diene. But the important part is that you have to also give the position of this double bonds. If that is the case, then the double bond is present at third and sixth position. Therefore, the primary suffix will be 3,6-diene. So this is the primary suffix for the given compound. Now moving on further, next we have the secondary prefix. Two substituents are attached to the main chain and they are present at second position and eighth position. If that is the case, what we can say about this secondary prefix? It will be 2,8-dimethyl. So di, again, it is used here because two methyls are present in the given compound, similar to the double bond. Okay, so therefore 2,8-dimethyl is your secondary prefix. Now moving on further, next what we have? So next is putting the given suffixes and prefixes in the complete nomenclature. So we have the secondary prefix, we have the word root, we have the primary suffix, which is 2,8-dimethyl for secondary prefix, dec for the word root, 3,6-diene for the primary suffix. If you combine all of this together, you will get your complete name as 2,8-dimethyl deca dash 3,6-diene, or we can also write it as 2,8-dimethyl dash 3,6-decadiene. Okay, either you can place this 3,6 before diene or you can place it before deca. Both are correct in a way. Now continuing with the second compound, so we have done the nomenclature for the first one. In the second compound, the only things which are present are word root and primary suffix. Apart from this, all the other secondary prefix, primary prefix and secondary suffix are absent because there are no branches, no functional groups and no cyclic compound. So if this is the case, we can move on to the second step of naming this compound. What is the second step? It is deciding the word root. So for that, you have to take the longest carbon chain. That includes the double bond as well. Now, if you look at this given compound, it is very clear that there is only one chain which is possible. And this one is represented here. And in this one chain, 8 carbons are present. So the word root is oct. Therefore, we can say that the word root for the given compound is oct. Moving on to the third step, what is that? It is numbering. How you will do the numbering? So if you do the numbering from the right and from the left, you will get the same outcome, that is 1, 3, 5 and 7. Okay, if you look upon the option A and B, the substituents are present on 1, 3, 5 and 7. I would not say substituents, I would say double bond. So numbering is 2 from either side, and you can now conclude that option A and option B both are correct. Now continuing with the next step. What is the next step? It is giving the primary suffix. So the double bond is present. Then if double bond is present, what we can say? that primary suffix will be "-ene", which is E and E. Since 4 double bonds are present in the given compound, so you have to use the word tetra as prefix. Therefore, it will be tetraene now. Apart from this, you have to also decide the position of this double bond. So what will be the position? We have already seen this. It is 1, 3, 5 with commas. Then we have dash tetraene. And this is clarifying the position of double bond. Moving on to the next step. Next is putting all the parts of your puzzle together, that is word root and primary suffix, which is oct and 1357 tetraene. If you put them together, then the complete name would be octa 1357 tetraene or 1357 octatetraene. Both are true. Here also you remember that we are including the letter A. You will see that after oct we have written A. Okay, so we have written A here. Why is this A written here? Because there are vowels present. Okay, so for that reason you have to use the letter A in case of multiple double bond. Now continuing further, moving on to the next compound. So here is your third compound. What can you say about the prefixes and suffixes that are present in the given compound? So it has secondary prefix because of the branching, then it has word root and primary suffix. So I have designated the longest carbon chain in the starting part only so that you can notify that there are branches present in the given compound. Continuing further, what we have next? Next we have the word root. So you have to decide the longest carbon chain that contains the double bond. So this is important because the presence of a double bond affects the naming of the compound, indicating unsaturation. Now, if you are selecting the longest chain, then you will see that this is the longest chain which is possible, which is being squared here. What is the counting of the carbon? It is 5, so the word root is pent. Now moving on further onto the third step. What is the third step after deciding the prefixes and suffixes and then assigning the word root? It is numbering. So numbering is crucial here and it can be done in two ways. Either it can be option A, which is 1, means the position of substituent is 1, or option B, where the position of substituent is 4. So the lowest position here is obviously in option number A because 1 is less than 4. So the option A is the correct numbering. Now moving on further with this correct numbering, what we can say? We have to decide the primary suffix now. So primary suffix is decided by looking at the double bond. So double bond is present here. We can clearly see it. Therefore, the primary suffix is "-ene". So in conclusion, we can say that your double bond is present at first position. Therefore, your primary suffix will be 1-ene. Now next we'll move on to secondary prefix. So what about the secondary prefix? For that you have to look upon the substituent. You can clearly see that there is only one substituent which is attached to the main chain. And what is that name? What is its name? Its name will be N-propyl. And this N-propyl is present at the second position. Therefore, the secondary prefix for the given compound is 2-N-propyl, or you can say as 2N-propyl. Next, so we have done this work of secondary prefix. Now, what we will do? We will write the complete nomenclature. So we have all the parts of the general configuration of writing the nomenclature. We have the secondary prefix, we have the word root, we have the primary suffix. So secondary prefix is 2N-propyl, word root is pent, and primary suffix is 1-ene. Therefore, you can write the complete name as 2-N-propyl pent-1-ene. Okay. Moving on to the next question. What we have? We have the compound number 4. What can we say about the compound number 4? So I have already identified this longest chain. Then it is clear from this that your secondary prefix is present because some of the carbon is out of this longest chain. Okay. So secondary prefix is present, word root is mandatory, primary suffix is mandatory, and primary prefix and secondary suffix are absent due to absence of this cyclic group and functional group. Next, what we have to do? Next, we have to decide the word root. So what we will do for the word root? We will select the longest chain that includes the double bond. If we do so, then this is the possible longest chain that is including the double bond as well. If you count the number of carbon, then it will be equals to 10. So the word root is dec. Now next, what we have to do? Next, we are concerned with this numbering part. Okay. So what are the possible ways of numbering this compound? In the first option, the possible numbering is 579. Okay. And in the option number B, the correct numbering is 246. Okay. So these are the two possible numberings. So the correct one is option number B. Why? Because the sum of 246 is less than the sum of 5, 7 and 9. Now moving on further, what we can do? We will now decide the primary suffix. So to decide the primary suffix, you have to give the double bond. Okay, you have to look upon the double bond. So yes, the double bond is present. It is present at the 4th position. Therefore, the primary suffix is "-ine". And what about the complete primary suffix? It will be along with its position. So it is present at 4th position. Therefore, the primary suffix is 4-ine. Next, what we have to do? We have to decide the substituents. Okay. So to address the substituents, we have the secondary prefix. Now, the secondary prefix, for the secondary prefix, 3 types of substituents are present. First is at the 2nd position, then we have at the 4th position, and then we have at the 6th position. What are the positions? What are the names of this position? So we have methyl and ethyl. There are 2 methyls on 6, 2 and 6, and 1 ethyl on 4th. Therefore, the complete secondary prefix will be 4-ethyl -2, 6-dimethyl. We are using di for 2 methyls. Now continuing further, we have to put all of these parts together. So what is the complete nomenclature? Therefore, secondary prefix plus word root plus primary suffix, which will give you 4-ethyl -2, 6-dimethyl plus dec plus 4-ine. Therefore, the correct name of the compound is 4-ethyl -2, 6-dimethyl dec 4-ine. Now, next question. You have to just count the number of sigma and pi bonds present in the structures 1 to 4. How you will do it? So, the number of sigma bonds is 33 and pi bonds is 2. Then in the second compound, if you see, the number of sigma bonds is 17 and the number of pi bonds is 4. You can directly look in the image. Okay. Then next, the sigma bond count is 23 and pi bond count is 1. And lastly, the pi bond count is 41 and 1 and sigma bond count is 41. Now there are cases where we have complex branched alkyl groups. What we will do in that case? So we have already dealt with this. So complex branched alkyl groups have numbering for them itself. Okay, so they require special numbering. So each branch is treated like a smaller carbon chain. So we can have an example here. So apart from the longest carbon chain, the boxed part is the branch, and this branch is a complex one. So we have to give a numbering for it itself. So 1, 2, 3, 4, and the numbering starts from where it is attached to your main chain. Okay, you must be seeing here that the numbering is starting from the attached part, from the point of attachment. Got it? Now, if this is true, we can have an example here. In the given compound, 3 things are present: secondary prefix, word root, and primary suffix. Primary prefix and secondary suffix are absent here. Next, what is the part? We have to decide the word root. So the longest carbon chain is being given here, which contains the most number of branches. So this is important to notice that you have to look for that longest carbon chain which has the most number of branches. Now in this, two possible chains are there with the same length. So this is the first one and the second one in the option A and option number B. But in the first option, the number of substituents or the number of branching is greater as compared to the option number B. Therefore, what we can say that the correct option is A. So more branches is present with the first one, which is 3. And in case of option number B, then branching count is 2. Therefore, the word root is deck. So that is for sure, because the longest chain is of the same length in both of the cases. We have to decide one of them. Okay. Now moving on further. Next is the primary suffix. So for the primary suffix, we have to look for the double bond. So no double bond is present here. Therefore, the primary suffix is "ane". After that, what about the numbering? So you have to give the substituents lowest possible set of numbers. According to that, two options are possible. A, in which 688 is the numbering, and B, in which 335 is the numbering. Now, we can clearly say that option B is correct because it gives us the lowest sum, which is 11, okay, as compared to the option number A, which is 22. Now, we got our correct numbering, therefore we can move on to secondary prefix. So 3 substituents are attached to the main chain, which is 2-ethyl-butyl, methyl and methyl. So how this name is kept, 2-ethyl-butyl, let us have a look on it. So for that, what we are doing a separate numbering. Okay, so that is starting from the point of attachment. And in this view, on the second position, we have this ethyl. Therefore, the complete name for the complex branching is 2- we have ethyl-butyl. At the third position, we have 2 methyl groups, so 3, 3 dimethyl. At the fifth position, we have this 2-ethyl-butyl. Therefore, 5-2 ethyl-butyl. So 5 is denoting the presence of this or the position of this complex branch, and 2 ethyl-butyl is denoting the branches of the complex branching. Finally, we can just write them together and give the complete name as 5, then in the bracket 2 ethyl-butyl, then after closing the bracket 3 dimethyl. Okay, so this is the secondary prefix for the given compound. Now placing them all together, what we can say, the complete nomenclature will be included with secondary prefix, word root and the primary suffix. Therefore, the complete name is 5-, then we have 2 ethyl-butyl, 3 dimethyl decane. This was all for today's lecture. Thank you for joining the session.